Hello class again and welcome to this particular video, and in here we're going to be exploring angles, and this is going to be a new chapter which deals with measurements and geometry. And so it's really fascinating to see how we're going to connect two things in here, one involving giving two lines, how you're going to find the space between the two lines in terms of measurement. And so this is where our bell work comes in, so please make sure you grab your notes and your pencils, and then you write the bell work down, which states that first we need to know what the lesson is, which is line and angle relationships. That's our goal, and our goal specifically is to be able to define what a line is, what an angle is, identify and measure angles formed by intersecting lines, and we're going to be drawing lines with the given measures of angles. So all these three things are what we're going to talk about, and so please focus and let's get this started. So first off is the question, what is an angle? And an angle, of course, is a space between two intersecting lines or surfaces. So if you're asking yourself what is intersecting, it means that when two things they meet, that is called an intersection. And you can notice that when you're driving or when you're walking on the road, and when you hit a particular point where you have to look before you cross, that point before you cross is where two streets or one or two more streets they actually meet. So this is what we talk about when we talk about intersecting lines. So when two lines they meet at a point, the space, which is where those two lines don't actually play around with. So if your line goes this way and the other line goes this way, the space between the two lines are called angles, and this is actually measured in degrees. So please keep that in mind. So if you want to measure the space between angles, you want to know that that particular measurement is in degrees. And you're asking yourself another question, what is those specific ways, or how can you measure angles? And a cool way to measure angles, take note of, is by being able to notice some key areas. So degrees, take note that the symbol of degrees is when you're given a number, that is how much the space is. The little knot at the top right of that particular answer or number is called degrees. So keep that in mind. And we're going to look at various examples as we dive into detail. Like for example, let's say if you're given a line here and you have another line here and they meet at this particular point, this is called the intersecting point. I'm just going to shade this. This is the point of intersection. Intersect point, that is where they meet. This particular space that you see right here is called the angle, and the angle is a specific number in this case, which is represented as the degrees. So if the number here is, in this case, space is measured as 90, then it means that the angle is called 90 degrees. So that is how you measure the angle of a particular intersecting lines. So going back to, or moving further, or asked how to measure angles, and you're looking at this here and you're wondering, what are all these objects or specific materials doing here? How are they common? Now, one thing you need to keep in mind is, before you actually tell you the question, figure out how do these particular images, what do they have in common? And once you hit play, then we're going to continue. And yes, so in here, take note that this particular device, which we call a protractor is a device that is used. Protractor is a device that is used to measure the angle that is made between two or more intersecting lines. And so this protractor, you notice that the shape is from a circle. So, but in this case here, it is like half of a circle, which we call, in this case here, half of a circle is called a semicircle. And in a semicircle, we know that the space that is covered from one end all the way to the other end is around 180 degrees. That is the angle that is made. And what we notice is that the same thing is shown in terms of this particular device measuring tool. What you see here, if you zoom in, is that, hey, we have, starting from this barrier of our specific measuring tool all the way to the end, it starts at 0, and you have the calibration lines, and it ticks all the way to the top, which is measured as 90 degrees, and then it goes all the way to 180 degrees. And that actually is what is a measure of the space covered from one end of a line to the other end of that same line. So 180 degrees is one number you should familiar with, you should remember. And the other one here is that half of a semicircle, which is like a quarter, or some people call it quadrant, is going from 0, you go all the way to half of 180, which is in this case 90 degrees. That's what we see right here as the 90 right over here. So you can either measure from one end of this straight line here to the other end, which is 180, which is one thing you should remember, or you remember from one end to half of the other end, which is in this case 90 degrees. So in here, you can also do it the other way around by using the other method. So you can go from this 0 here, which is the next after 180, you can start to 0 here. It goes the same measure, is called corresponding angle. Keep that in mind, because on our next video we'll talk about it. And it will hit 90, and then look at this again, it goes all the way to 180. And this is applicable when it comes to various streets. And what we see here is that we have a little circle here, and this little circle is kind of like a roundabout, as you see in specific streets, and you have lines coming out on both ends of that circle, and you see the cars moving around the circle in order for it to enter a new street or the same street. And this is a way to control traffic, and some countries, they do use this particular method in order for them to overcome various crashes when coming into an intersection. So in here, what we can see is, if I use this line and I drag it here, that is one line, and we pick this line and we drag it over here and we pull it over there. This shows the intersection right here. And so these two lines, they intersect at this particular point. And if we have our circle, which we notice, and we bring it right over here, which has to be out. Let me bring this out, or bring it, let's move this. Can I move this? No, I can't. I have to go this way, bring it here, and then bring it front. Perfect. And so I bring it over here. So it is like a target point, if you look at it that way, and you can actually measure all these spaces that is made from one line side to the other line side by using a protractor. So all you have to do is you bring your protractor. Let me bring this to the front. Where is the other? To the front, and then lay the straight line on the vertical line, and lay the horizontal line directly on the horizontal line, and you can measure the angle. And what we see, if you line it up properly, is that, hey, we indeed have a specific measure of the angle, and by aligning it properly we'll be able to figure out that the angle is, in this case, 90 degrees. Let me line it up properly. So that's how you use a protractor to measure the space made between two intersecting lines. So in conclusion, the 4 or 5 specific objects that you see, they have things in common. One is that you can represent a real life example in the form of lines, and then you can measure using a specific protractor, which is, in this case, proves that yes, the two lines, they meet at an angle which is 90 degrees. And if you say the two streets, what are the two streets angle that is being made? And you can see that for one street alone, going from one end all the way to the other end, you measure and you look at the number, it is here, and that is 180 degrees. So this is a wonderful way for you to actually check this out and get yourself a little bit, play some nice little fun activity with it if you feel like doing it. And definitely, now the next one here is focus on lines connection with angles. And what we see here is that yes, we do have definitely straight lines, and from a straight line you can introduce a new line, which is what we have right here. So I introduce this line, and no matter how I place this line on the green line, they don't intersect at the point. All places except for this region here where all points are all touching both lines, but I want these two lines to intersect at the point. So to do that, what I have to do is move the red line, rotate it, for it to touch starting from here. The green line at a point, I do it again, another point, another point, another point, another point. So the more I move these from right to left or counterclockwise, which is opposite the clock movement, we see that the angle gets bigger and bigger and bigger and bigger. And so once it starts from here, which is usually at, let's say, 1 degree, this is 2 degrees, 3 degrees, 4 degrees, 45 degrees, goes up 85 degrees, and then 90 degrees, which is some kind of a T. And that is what makes this particular relationship really cool. We can determine or approximate what angle is made when two lines are touching each other. So remember, you're going from smaller angles, in this case, to bigger angles, going from right to left or counterclockwise. And then you can also, this is in this case 90 degrees, and then you can also move around, increasing from 90 degrees, looking from right to left, and all the way to the other end of the green line, which is in this case around close to 180 degrees, assuming it is straight on this part lane on the opposite side of this particular line, which is something like this. So this will be 180, this will be 90 degrees, and let's just make this touch here. Yeah, perfect. And this is around 0 degrees. Let me put this properly, align it properly so that it works really well. Yeah, that works in a way. Yes, so that is how you're able to determine angles and measurements. So angle in a straight line, in here we have a straight line, and it actually comes in one or two ways. One is either the other line crosses completely through a particular straight line, or the other line touches but doesn't cross through the other straight line. So whatever straight line you pick, if you pick this line here, which is the vertical line, as your straight line, then it means that this one will be the one that you are going to be cutting through, or the opposite. If this is your straight line that you pick, this will be the line that will be cutting through the particular horizontal line. And the same thing here is applicable, but in the opposite way. So in this case here, there will always be a straight line here. In this case, that the other line will have to touch. So it feels that this line here, which is the vertical line, is touching the horizontal line. So by default, this line here is considered to be your specific straight line. So in here, we're going to look at various examples that you're going to come across on your specific activity, where you will going through question 1 and question all the way to question 5, and you'll be asked to, match specific angles given to the respective lines intersections. So one example in this case would be, in this case, if you're given a question that says that, hey, you're asked to determine what lines that intersect at a point represents 90 degrees, and another one will be 45 degrees, and another one will be, in this case, let's make the other one to be 135 degrees. And yeah, those are the given angles. So for A, what is it like to have 90 degrees, and for B, given 45 degrees, what is it like giving 2 lines, and for C, what is it like to create 135 degrees giving 2 lines. So if you're given 2 lines here, let's make this line, let's say a green color or orange, doesn't matter, and we're asked to create 90 degrees. So to create 90 degrees, what you have to do is, you notice that, hey, whatever line I pick doesn't matter as my straight line. Either I pick this line here or this line over here, and then whatever line I pick, in this case I'll pick the blue line as my straight line. I'm not going to move it, I'm going to keep it straight. And what I'm going to do, I'm going to move line 2. And if you look at here specific angle measurement, what you notice is that if I drag my specific or copy, let's copy this and bring it right over here to use as my measuring tool, copy and V, what we see is that to create 90 degrees, you can predict also that, hey, I have to move this orange line all the way to form a vertical line. So where a vertical line and a horizontal line, they meet, indeed they create an angle that is indeed 90 degrees. So this, in conclusion, let me move it back here, is measured to be 90 degrees. So let me move this. This doesn't agree. It's not agreeing with what I want. Okay. Okay, so what I'm going to do is I'm going to move this over here and move this over here just to play it safe. Okay, doesn't want to agree. So yes, so in this case here, this is measured to be equal to 90 degrees. So now, once you have this taken care of, our next step will be perfect. Now I'm good. So I'm going to move this back here. I'm going to move this up here, and that is 90 degrees. So another one will be, what if you want to determine what a 45 degree looks like? And so to create a 45 degree angle, in this case for question 2, which is B, you're asking yourself, what is 45 degrees? So 45 degrees, you know that it's half of 90 degrees. So in this case, to show that, first, let's start with this particular, let's get this out of the way. Let's pick a, okay, so let's erase this. And first, let's show that this angle here is 90 degrees. And so eraser, and to show that this angle here is 90 degrees, what you do is you draw a particular shape that looks like a curve, and then you draw an arrow and you put the angle here to be 90 degrees. And yes, that is the measure for 90 degrees. And the other one here is, what if you're asked to determine a 45-degree angle? And to go about that, what you do is you adjust this, because we know that it is not 90 degrees but 45 degrees, and to get 45 degrees we go half of 90 degrees. So what you do is you rotate it to the point where the space is half of 90 degree space, and somewhere around here. And if you want to check to confirm, then it means that, let's move this down here and move this right here. What you check to confirm is you use this particular protractor and you drag it. Let's get this out of the way. Okay, I know what to do. I use this first, and then click on that and drag it over here, and let's see what the measure is. So it is close to 45 degrees, but I was kind of almost right. So if you want to do it to adjust it to 45 degrees, you start from 0 here, and then you move to this 20, this 30, this 40, and this is around 45 degrees right here. So yes, so this measure is indeed 45 degrees. So that is a nice way for you to check using a protractor. And so from the blue line to the orange line, the space here is 45 degrees. And so that is how you're able to use these particular tools here to determine specific angles. And once you have 45 degrees and this one here, you've actually determined the 90 degree. Next one is, how about 135 degrees? And you're asking yourself, how do I get the measurements for a 45 degree angle? So to do that, let's copy and paste this line, and let's do 135 degrees, and this one as well, copy and V, and we drag it over here. So we know that this is 45 degrees, and we know that this straight line here, vertical line, and a perfectly horizontal line is 90 degrees. So that means I want to go more. I can go this way as well, or I can go the other way. So whichever way you want to go, that is completely fine. But make sure that the bigger space between the two lines, it shows that you are going more than 90 degrees. So if I go this way, yep, that will work too. And let's see whether this will give me 45 degrees by using the protractor. So by using the protractor and confirming, we can determine what the angle is by laying it on top of the other. And what we see is that this is 120, this is 130, and this is around, yes, 135, using the border line right here. And yeah, that is pretty cool to see this play out. And if you want to also use the other side, which is 90, and you want to go to the left or counterclockwise, you can also do that and check for 135, which is almost halfway. So if you use this borderline, what we see is that this is 90, this is 100, this is 110, 120, 135 is right over around here. And so that is another way. And you're asking yourself a question: what do all these angles have in common? When you notice it, what you notice is that to go from 45 to 90 degrees, I need to multiply that by 2. So which means that I'm going to increase the size of 45 degrees twice, and that will give me 90 degrees. And to go from 45 degrees to 135 degrees, I need to multiply this number by 3, which means I need to increase the number or space 3 times. And remember this, because these are a couple of key things to remember when dealing with angles like this. There are some angles that do relate, like for example this angle here. If this space, of course, shown is 135 degrees, so let me change the color size of this to make it look a little bit, make it look like degrees. Let me erase this because it doesn't work. So 135 degrees. This angle here, which is the corresponding angle, we're going to talk about corresponding angles very soon, is going to be equal to 45 degrees, because it's taking us to almost 180 degrees. So this angle right here is 45 degrees. So if I rotate it the other way around, it's also a mirror form of it. So keep that in mind when it comes to angles like this over here. So you're going to have a couple of questions you're going to be asking here to show intersecting lines. So what you have to do is just match the specific angle to the two lines that looks like 80 degrees or 105 degrees, that looks like 35 degrees, and also that looks like 55 degrees. And then for the other one where you have to draw two lines, so remember you have to draw two lines like what we did over here. And if you're given an angle, in this case 65 degrees, draw two lines and indicates the space that is 65 degrees in that particular case over there. So you're going to have a couple of examples and questions. Please make sure you are able to solve those questions properly and share it with me. By that way I can actually correct it and I can give you a go ahead to solve the problem. So thanks for following me through this, truly appreciate it, and see you all on the next video. Stay smart as always and believe in yourselves.